clearly what's going on. Also got the cross polarizers to see internal stress. We'll talk about that here in a moment too.
So I'm assuming if I put any of these on here, one of them shattered.
Right. These didn't shatter. There were two compositions that did. They're up here in their respective crucibles. So those two ended up having this kind of defect in it. They helped to shatter these two compositions a little less stable. Yeah. There are lots of sharps, so do be careful. I've gotten a little flake of glass sticking in here before. Yeah, it's way different than typical fiberglass because the larger spines, they flex and then all of a sudden they break and little pieces then straighten out and just get you right when you're not even expecting it. It's pretty crazy. It's just, but the problem with this is it actually like can poke in and then a little piece of the tip stays in your finger.
And then it's
in there. And then I still think I might have a little sliver because occasionally I'll have a spot that's hurting for no reason. So that has happened before.
my cousins are doctors. They can get it out.
There you go. Yeah.
I mean, he's an orthopedic surgeon, but I mean, he still some great things.
Yeah, if they can identify its location by X-ray, then they can pretty much get it.
Yeah.
I'm not sure. It's not like a big deal, but I've wondered if that's what. But it could also be other stuff. It could be metal slivers. Feels like I've done in the past. So.
We see things about like war veterans who still have like the bullet right on there. It just kind of creates around the prints everyone's on that.
Yeah, but it's nothing that extreme.
Yeah.
So.
Unless people are fighting back to each other.
Right. Hopefully not.
Just gotta take a couple pictures. On the other color. So let me go ahead and describe the jobs while people are finishing up here, and we'll get some volunteers. So I'm going to pass around these this master list that has all of the data. So grab one of those. Pass that around. So if you pass those around. And probably one per group would suffice, but if you want your own, probably actually one for everybody's probably best. First job is the Master of Ceremonies, which sounds very official. Your job would be to keep me coordinated to make sure I'm pulling the right crucible from the oven. And so typically the pattern is center, left, right, center, left, right, center, left, right as we unload the furnace. So anybody willing to help out with that position? Thank you, appreciate that. There was a couple crucibles that weren't labeled with composition, so I had to make an educated guess. Maybe you can clear that up for me. So one was labeled Noah and Joe, and I think that's T.O. Is
Yeah,
that
it's T.O.
T.O. Okay. Next was initials S.H. and then A.E., and I think that's R0. Is that true?
Yep.
Okay.
That is true.
And then I'm pretty sure with this one, but it was Q plus T, which I think was O0.
That's correct.
All right. So I had to guess based on the color of the powder because they were marked. They weren't marked with the composition. So anyway, thank you for that. Next up is the door. This is a double stop clamshell doors. The first half of the arch opens up the bottom, the second the top, and you have to be slow through the center. Otherwise, it can jar the top half. So you can go up and then slow, and then all the way back. I'll go in and grab the crucible with the tongs with my hand, and then as I'm pouring, you then have to go slow back through center and close to preserve the heat. And so you get some up close personal time with the furnace. But as long as you just kind of stand off the side and just take it through that arc slowly, that's a job for somebody. Anybody willing to be the doorman? Thank you. Appreciate that. Next up is the torch. So I've got a propane torch over here. Just getting a little bit light on fuel. I've got another tank though. So as I'm pouring, if we just grab one of these crucibles, I'll show you what that's going to look like. That one's got stuff in it. That would be a bad idea. So imagine this is glowing hot, and I'm going to be pouring these different positions. So you'll want to fire the torch. So it's a piezo actuated, so it's a slow push. So gas, then spark. And you'll want to heat the bead of glass that's dripping onto the puddle. And you just want to keep that glass bead hot so that it's the hottest part. Otherwise, what happens is you end up with all this fiberglass as I try to separate the crucible from the poured glass. And it just makes kind of a hazard, kind of a mess. So your job would then be to keep the bead hot, and then as soon as I break the bead away, you fire polish the top of the glass to get any strings to then pull into that mass of glass and get a nice smooth disc at the end. So anybody have any experience sweating pipes, doing?
Yes, whatever.
I don't know. Who's it going to be? Arm wrestling match? Okay. Well, I'll let you guys figure out that. I don't want to start anything there. You can settle that outside. I don't know. So there's that job. The torch work. A little pressure on that one though. Then next up, out of the way, the stamp. So this one, you get to feel the heat with this one. All of our compositions are ending in 0. So I've got these little dies, and so you will want to set those up so that they stamp properly. It's often going to look backwards to you when you look from this side. And so what I recommend doing is getting the set of dies that you think are right, and then you'll just want to kind of stamp it momentarily on your skin to make sure it looks in the correct orientation. It's easy to get these upside down. And my number set doesn't have a 0. So you use the O. Well, we have composition O0, so you'll have to stamp it twice for that one. And the radiant heat is kind of intense when you get that close to it. So I recommend wearing the rubber gloves. You might not think that's going to help much, but it cuts down on radiant heat by a lot. I've got insulated gloves. Sometimes a torch uses those, but these are really hard to hold the stamp. So the rubber gloves work. So anybody want to do the stamp procedure? You get to get really close to scalding hot glass. It's really exciting. All right, thank you. Got the first one queued up there for you. Then we've got the fireman. This person has never actually had to do anything for the 10 years I've been doing this, but it's always good to have it there. And somebody did point out that I'm using a past dated fire extinguisher. This is kind of the one that's, well, it's last inspected in like 2001. Is that even possible? What's that? Well, it's carbon dioxide, and I can feel it's full. It's a liquid. So I think we're still just fine. I'm usually one of those guys that lives on the edge, I guess. But what could possibly go wrong, right? So,
Especially right now.
right. If you have a fire and it doesn't happen, then there's another one out in the hall, by the way. But fire blanket too, right? Anyway, so I've got a long-standing gripe about fire extinguishers. I'm used to having a lot more around than what the school provides. And they say the reason for that is we don't want you fighting fires. We want you to safely and calmly exit the building. And I'm like, well, what if the fire is blocking the exit? We don't want you fighting fire, just safely and calmly exit the building. What if you are on fire? We just want you to safely and calmly exit the building. So it's like a broken record. I can't get anywhere. The regulation federally is it has to be, I think, within 50 feet or 50 yards of every point. And so they're strategically placed in the hallway to have a certain radius. But in grad school, there were like 2 different types bolted next to every fume hood. And that would be a lot in this room. So probably there'll only be maybe 2 sets. But anyway, they say we don't get fire extinguisher training. You ever had fire extinguisher training? It's the word pass. Every fire extinguisher training I've ever had. Really difficult. Pull the pin. I'm not going to squeeze the handle, but pull the pin, P. You aim at the base of the flame. Not the flame, the base of the flame. Shoot where the fire is coming from. And then you squeeze, you sweep side to side. PASS, pull, aim, sweep. Pull, aim, squeeze, and sweep. Now you guys are fire extinguisher trained. So anybody want to stand there just in case I catch my pants on fire?
Sure.
All right, thank you.
Sure.
The scenario that could happen in is the crucible drops or breaks, and then the hot piece of ceramic were to hit your clothing. It's like a foundry. It can immediately ignite your clothing on fire. It's really exciting. So that's just in case. Hopefully it'll never happen. So, all right, I think that's all the jobs. So questions? Do wear your goggles, because some of these glass compositions, I don't know what's going to happen today. These are completely new glass compositions. But what will happen is if they can't handle the stress during quenching and cooling on this metal plate, they will actually just shatter, and they sort of break apart and then throw pieces out this way. They don't like completely go off like a grenade or anything. It's usually just a straight out. But we'll pour the glass. It'll take about half hour. We'll then watch 2 5-minute videos on some different perspectives on glass. And then we'll hopefully get this cool enough that I can move them over to the light table and we can observe the compositions. I am recording this so it can be observed later to compare the viscosities during the pour. So this will be posted, but it's just this block right here is the go zone for pouring. So I do have to wear a shiny suit, because otherwise my shirt would catch on fire toward the end. I tested that once with a piece of paper, and it does. It catches on fire. If you hold a piece of paper right here and slightly open the door, it will just burst into flames. Spontaneous combustion from radiation. It's pretty cool. Actually pretty hot. But anyway, and if the torch starts feeling pretty hot, you might need one of these, and your angle is to typically try to point it towards the set of discs that's been done. Then we'll pour the next ones, and then you got to be careful not to put the heat angle towards the previous cooling one, because sometimes that can heat stress them a little bit. So you're kind of always pointing towards the most recently poured, and you're going to be kind of going across like this. All right, and the best place to stand is probably right here for that. Got the door ready. All right, so we're first pouring composition M0, right?
So you want center one?
Yes, that's right. So M0 is a standard soda lime glass with praseodymium. Praseodymium. It's a greenish color typically. So hopefully that's what we will get. And so this one will be probably the best one to gauge the viscosity on, because this is the standard soda lime glass. So we'll be pouring it right there. So give me a little bit of room, and you don't necessarily have to pour it, but just, as long as it's close by. So we all ready to go? Okay, so let's pour in 0. So slow through center. That way it can go a little bit faster. So slow down right.
It's one in Cuda. This one was MO, correct?
MO in 0. You can get the flame a little bit closer here toward the end to get that be the glass be the hottest part. And then polish that down into the surface. All right, that looks pretty good. So then stamp right about there. Yeah, we're at the bottom edge. That's good. Just kind of set the surface. All right, perfect. So far, so good. How's it going? Just say, need something?
Oh, just I need some of these.
Yeah, we've still. Oh, for Shell.
Yeah.
Yeah, we've got more of those probably
There's a
downstairs.
stash. Yeah. Centralized.
Is that enough? How many do you need?
This is one.
Okay. Fair enough.
Hey,
Next is
Yeah, making some glass here.
I like the suit.
Yeah, it keeps me from catching on fire. So, all right, that's a nice bright green color. And so we're focusing a bit on the top row rare earths. And so keep in mind we're going to be using praseodymium number 59, neodymium number 60, and then there's some erbium number 68. So these are kind of interesting colorants and kind of rare, but not that rare. They're called rare earths, but they're often found in calcium phosphate minerals, and so they're not that rare. But China has the biggest deposit on Earth of these things. But anyway, we'll see some of those. So next up is N, and N0 is a higher. What do we do here? It's actually very similar to this with a 5-gram load of zinc oxide. So that's right, I did a zinc study. So we're going to have 5, 10, and 15 gram zinc loading into the glass. So we're modifying the composition. I've never done zinc glass before. I don't know what it's going to do. Hopefully it's going to do something cool. This next one is 5 zinc with 4 grams of neodymium. So this should be a bluish color. All right, it's pulling from the left. I think that was lower viscosity, but I bet it seems like it's poured a little easier. It's making me wonder what the 15% or 15 gram zinc's going to do. So this is going to pour out like crazy. That is way different. I know it doesn't look like that different to you yet, but if you eye the diameter, you can see that the diameter is much bigger on that one. Yeah, so that's going to sink down a little thinner. If that continues, this next one is going to be even bigger through the set. So that would be standard soda lime, 5, 10, and 15 gram zinc added to the batch. So we'll see. Should be kind of cool. So we'll try to hit this one. Next one's right there. Might do the next one on from this one. So neodymium makes glass blue.
From the right.
Oh, and is that medium zinc? Is the heat too much? Or are you able to?
No,
if you
it's
want to get the
fine.
glove, feel free to do that. It does get kind of toasty on a few of them. So, yeah, medium zinc, erbium, and erbium is pink. So, yeah. All right, it's pulling from the right. Oh, nice. The question is, does the trend continue or does it kind of level off after you get a certain amount of zinc? That's not like super different.
That one's a bit more boosters.
Yeah, so I don't know. Let's try to look a little closer here in a moment. But some less graphics. What you're hearing here is called crazing. As the ceramic shrinks at a different rate than the glass, it will actually pop cracks in that thin layer of glass that's on the wall of the crucible. And so you've probably seen crazes in glazes before on dishes, and you might not know what those were. So as it shrinks, like I just saw a huge one form right there. If you watch that thin layer, you can literally see cracks forming before your very eyes. And they make that interesting sound. So, all right, it is bigger, but it's not as big of a jump. So I think we'll pour the next one right here. And it is
PO high zinc.
PO.
Middle, it's slightly askew right now.
Yeah, it got tilted a little bit in that last grab. So this one is high zinc with a two-part combination. So I cut back on the loading, and I mixed two-part mixtures of each of these different colors. And so this one is praseodymium neodymium, and so I'm trying to achieve a midpoint color between these two. And the higher zinc presumably will make this spread a little bit more. So that's where we're headed. Okay. So I'm hoping for kind of a blue-green out of that. Trying to clear the deck here. Okay, so I think that's working. Yeah, and it's a little bit subtle. It's like there's a big jump when you add the first amount of zinc, and then it is changing though. So they're all increasing by just a little bit. And the gram loading of each of these batches in the crucible is the same. So the change in diameter has two different effects. You're probably getting a little more out because the viscosity is lower and there's less clinging to the crucible. And since it's pouring easier, it spreads a little more. So diameter is kind of a qualitative assessment of viscosity. Where thinner or lower viscosity is larger disc, higher viscosity is a smaller disc. All right, so the next one we'll pour here is
QO.
QO.
That note is high flux.
High flux, okay. So then that's the standard. It's the standard soda lime glass with no zinc, but a higher loading of flux than the first one. So we get a nice comparison there. The colorant on this one is praseodymium erbium. So praseodymium erbium, that's going to be a combination of the green and pink, which I have no idea what that's really going to look like. It's a nice greenish pink color. Is that brown? The green and red makes brown, right? We'll see. So we'll pour that one right there. What's that? Yep, on the left.
color will it be? Sometimes it gets a little sticky. You know, for it to cool enough to get brittle and break off. But almost looks orange or yellow at the moment.
I was thinking like honey.
Yeah. Now, sometimes it takes a little while for the color to set. That's called the striking temperature, the temperature at which the glass attains its final color. And as it's cooling, think about what's happening. The bonds are all vibrating, and then they're getting smaller and smaller in the amplitude of the vibration. And as it settles then on each metal center in the glass that's coordinating usually with oxygens, it then will reach its close enough to room temperature conformation to get your final color.
Does it matter if it cools at different rates?
I mean, it's not as sensitive as like alloy composition, but that's an interesting question. Could you quench a different color into glass by cooling it really fast? It'd probably shatter it, but what would it do with the color? I don't know. My guess is it's probably going to be the same since it's not a crystalline material, since it's amorphous. But I don't know. Can you quench a different color into glass? I've never thought of that. Interesting question. I don't know. I have to look up, see if there's any precedent for that.
R0.
R0. So that one is,
Low flux.
yeah, so that one is not quite as low flux as the lowest flux. You see C0 on your sheet. Those didn't turn out as well. They were super low. But the low flux should be distinctly different than this one. So if this is medium or this is average, high flux, bigger disc. Low flux, this one's going to be really bashful. Come out of the crucible. And then we're coloring this one with neodymium erbium. So this will be blue plus that. I'm hoping for purple. I don't know. I didn't really get much color out of that one, so I think it'll be purple. Anybody want to take bets? It's a lock on purple. I'm pretty sure. So, all right. So this is which one? R. Okay. R0.
From the right.
You see how slow that was to come out? The problem with low flux is sometimes they're higher tension glass when you quench them, and so they have a habit of cracking, exploding, etc. So I should have poured. I might have been better to pour this one further away so it doesn't break other ones. But I don't know. We'll see. So just really hit that. Try to get that to sink in as much as possible. Probably about as good as we're going to get. It's going to be hot. All right, so that definitely told the story. It's thicker. Get this thing to let go. Here's some real estate here. Okay, so again, that is not purple.
Yeah.
I'm kind of confused by that. It's like the erbium is canceling the color of the others somehow. With the other transition metals, it's more reliable. I can take cobalt blue and mix it with some of the other colors, and it's more of a standard mixture. But in this case, it could actually be doing something different chemically that's leading to a different way of interacting with light. So we'll see what that ends up. All right, so next up, I think we're transitioning.
And it's at L plus weight.
Low aluminum, okay. Yeah, let's put that one. S. is a higher flux composition. So it's actually identical in composition to this second one, except instead of adding zinc, I'm adding 5 grams of aluminum. And aluminum has a way of tightening up the glass and making it more viscous. So I'm kind of expecting something a little, I don't know, probably somewhere in between these three right there in that swing. So the color on that one is manganese, which is supposed to be purple. Pretty sure this time. Would have lost that bet, right?
Dude.
All right.
That's from the center.
Yes, from the center. Wait too long, my gloves start smoking. It's more of a subtle effect. It's not really saying
Two for two with the purple.
It's not really saying purple, is it?
Were they mixed on?
I don't know. I've got some examples of manganese glass from the past. It's a glass from the past, not a blast from the past. So I can show you what that composition typically looks like. I mean, we might have had a pretty low loading, but still, we should be getting something out of that. I don't know. We'll let it cool down. So next up, we'll put it there.
Oh,
TO.
Joe's.
We've got, this is the first borosilicate glass. And so these with the boron are in the Pyrex family. So lab glass is made out of Pyrex, has a lower coefficient of thermal expansion. These aren't optimized for that. I'm expecting them to pour out really well, maybe too well. Haven't done a lot with the boron glass in the past. This one is about as high boron as any of them. And then we're adding in copper manganese. This should be purple. This should be bluish purple, ideally. Right. I don't know, did that even get color in it? You know, we were having a problem with manganese on Tuesday. I wonder if there's something up with the bottle that was pulled. Was it somehow magnesium and not manganese? I'll have to review and see what is going on there. So I guess I don't know what color this will be. We'll wait and see. Geo.
From the left.
From the left. Holy cow. Try not to breathe that. We'll put that back in here. Well, what am I going to do with this? I want to breathe whatever this is. Fire brick in the fume hood. It's probably going to cool off. I don't know what that is. That's unusual. It's obviously oxidizing with something in the air. It's stopped. I don't care anymore. So.
Kill us anyway.
We got pretty good airflow in here. So compared to a foundry, it's probably nothing. But I usually don't like having spurious off-gassing from my experiments outside of the hood. So looks kind of purple. Boom! More blue.
It is.
It didn't really smell much. Did you smell much? So I'm not sure what that was. Looked kind of angry. So the boron is definitely helping that spread out. Hopefully it's stable enough that it's not going to crack or anything, but super low. You.
Board looks under.
That's the right color.
Yeah, another latch or something. Yes.
He measured it, I know.
Yeah, so this was lower boron and some aluminum, a little lower, and then cobalt, manganese. Should be kind of purple. I don't know. Hopefully this one's not going to start smoking because, you know, Stout's a non-smoking campus. So I don't want to get things in trouble from that. So we'll try to pour this one here. It's probably going to be a little large. So
We're all dead inside at this point.
you from the right. Okay.
Everything kills us.
There it goes again. Nice. Cobalt blue is super dark blue. And so I was hoping to tilt that a little more towards purple. I'm going to turn on the other hoods and increase the airflow in here. We'll just turn them all on and have a higher clearance rate. You gotta walk around twice and turn off the low flow alarms. So just a second. Safety low alarm has to boot, and then it usually goes into an alarm state. So, finally.
Oh, that's what you get.
All right, almost there. I don't think there's anything really toxic coming off, but you've probably heard of welder's headache. Have you ever heard of that? Little bits of metal oxides can, I don't know, can give you a headache and kind of mess with you. So we'll try to get the vapors removed, whatever they are. They're hot enough, they're typically going to hit the ceiling and then head towards the hood anyway. I don't know, it's just kind of strange it's doing that. You think that anything would have burned off overnight that was capable of smoking. So it has to do something with the surface area, apparently. So, anyway. So this is, this is close to a Pyrex recipe, as probably many of them. So it's got the silica, sodium carbonate, calcium carbonate, boron, and a higher aluminum load. And this one's just straight cobalt, so we'll be able to contrast the color to see the effect finally of the manganese. So what's going on there, but pour that one right here.
In the center.
In the center, okay. Reach in the end. It's going to go eventually. We're going to that. There's some unmelted chunks in the crucible.
So we're still in the micro for 2 hours, so we put some of those.
Yeah, we'll clear the back. Yep. So far, we're doing pretty good. Well, I think we'll be able to just make them fit there as long as nothing spread too crazily. WO, which is chromium. So this should be green. And it's going to be a similar composition. It's just tilted a little bit off of the standard Pyrex. But we should get a green this hopefully.
From the left.
From the left, okay. I know in soda lime glass, it starts off brown. And chromium is the one that changes the most out of what we do from its initial color to final color. So this should be dark brown and eventually bright green. We'll see if it holds true. All right, from the left. That was brown. The problem with some of these is they're changing the base. So I'm citing how it behaves. Let me just kind of kick that underneath those. I'm citing how it colors in regular soda lime glass, and so that could be having part of the effect. But that looks clear. It looks like the chromium is not even in there. Is it possible the chromium is not even in there? I don't know. That's weird. Okay then. So one more. X. This is the one affectionately named everything. I decided to just throw it all in there and see what happens. So no idea. This could be really cool or really uncool. My bet's on cool though. I think it's gonna be awesome. All right, here comes it. Oh, hold on a second. So we reset that. That's about. Just going crazy. All right, so thank you for your help. That is the last composition. So I'd say go back and finish up with the crystal observations, and I'll queue up those glass process videos. What I like about these two videos is it shows you kind of the art side and the industrial side of glass.
Start class.
Yeah.
So you guys never smell anything coming off that paper, right? So all the ones that have boron right, did that. That's a mystery. Yeah, I've tried making those before, and I don't have the right glass composition. They shatter on us.
Well, we gotta.
We talked about that too, taking this and then crushing it and then putting it into slump molds or heat molds, and then it conforms to it. There is a way to do that. We typically haven't got it to that point, but we're working on it. So then you can actually have a punch in the glass.
Yeah.
Kind of dangerous, but that's what the ceramics blow up. But if you can anneal it at annealing temperature, it makes it stable. That could be done too.
Very, very slowly.
Okay. You can put it out, good, or out, it's got it away. Where do you get out? Yeah, I'd say we just pour it out on paper to see.
The 6 last.